All right. Good afternoon and welcome to Georgia DNR's Lunch and Learn webinar. I'm Emily Wingo of the Georgia DNR Floodplain Unit. First, a little housekeeping. We are in listen-only mode, so please make sure your mic is muted. If you're having Wi-Fi issues, you may want to turn off your camera and any other programs you have running. Please make note of the chat and Q&A features in the lower right hand of your screen and use them for communication. If you don't see the Q&A box, please look in the ellipses beside the chat. Reserve the Q&A box to ask questions, as we will not be taking questions by audio. Jeff Butler of Atkins is monitoring the chat box and will try to help you with technical matters. Please be sure to post to everyone when using chat or Q&A. We are offering 1 hour of continuing education credits for CFMs. In order to receive the credit, you must be logged in separately, answer all poll questions during the session, and provide your name and email at the end of the presentation. A copy of the presentation will be emailed to all attendees along with a survey that we appreciate you completing so that we can improve these webinars in the future. We also plan to post the video to georgiadfirm.com. Okay, so with that, let's get started. Today we have a presentation about the leveraging of BLE data through Georgia DNR's BLE Playbook. Our presenters are Joe Martinenza, Jarrett Mattli, Petia Doubrovska, and Megan Hanifan. Joe is a professional engineer with the Georgia Department of Natural Resources and has 25 years of experience with hydraulics and hydrology. He currently manages flood risk products for the Georgia DNR Flood Map program. Jarrett is a senior project manager based in Dewberry's Atlanta office with 17 years of experience supporting GIS and water resources projects. Petia is a water resources engineer with Dewberry's Atlanta office. She has a BS/MS in Civil and Water Resources Engineering and has more than 20 years of experience. Her technical expertise includes 1D and 2D H&H modeling, stormwater infrastructure analysis and design, and dam breach modeling for various private and municipal clients in Georgia. Megan is a water resources engineer in Dewberry's Atlanta office with 8 years of experience in floodplain management, stormwater modeling, and dam safety. With that introduction, I'll now turn it over to Joe.
Thanks, Emily. Let's take a look at today's agenda. We have a lot we want to go through. I'm going to start off by giving a BLE base level engineering overview, and then I'll pass it along and we'll discuss how BLE impacts things like floodplain management, planning and design, emergency management. And then if we have some time at the end, of course, we'll have a little Q&A, and we've got some resources that we can show to you. So to start off, whoever's driving, can you go to the next slide, please? Thank you. Let's just go over what is base level engineering. So we take a HUC watershed, a large watershed, and we create models for the floodplains. We do this in a very cost efficient way, but an accurate way. So we're not, in here in Georgia, we're not cutting corners. We're just doing it all at once. We're still going, we're using engineering principles and techniques, and we're creating these. So why are we doing this? Well, it helps provide planning level predictions for you. If we have new BLE, we can compare it to the effective floodplains, and we can start to get an assessment of, are the effective floodplains accurate? And then that helps us, that drives our scope of work. So if it's not accurate, if our BLE is drastically different from the effective floodplains, what we can do is we will create a scope of work. We'll do a flood risk project. We'll create new maps and publish those, and we'll have the most accurate data up on your maps. This is important. This way, we're not really wasting money doing studies in areas that don't really need new studies. But it also really helps highlight those areas that are in desperate need of studies. So that helps us set our scope. What is base level engineering? Well, it helps provide data and tools for you at the local level. I mean, that's really what we're getting. All this stuff, everything you see today is really set to help you at the local level. Okay, next slide. So what is base level engineering from an engineering perspective then? Well, the first thing is we will only do BLE in areas where we have LiDAR, which is really good really good topographic data. And I'll show you that in a little bit later on. We use two different methods for coming up with base level engineering. The first one is 2D models. This is something that, 10 years ago, even 5 years ago, you didn't see a lot of 2D modeling in the FEMA world. It was just cost prohibitive. It was time prohibitive. And to get the accuracy that you needed. But we can do that now. It's integrated into HEC-RAS 5.0 and greater. It integrates the hydrology and the hydraulics into one model. We use rainfall runoff simulations from HMS to come up with that hydrology. And then we actually calibrate it to the regression equations or gauge data if the gauge data exists. So we're not just creating very fast models, we're going back and calibrating to make sure they're as accurate as possible. Of course, we still do, I would say 2D models we tend to do in areas that are unconfined flow, interbasin flow, flat areas that 1D modeling traditionally just does not do a very good job. And here in Georgia, everything really below the fall line, if you know what that is, it kind of cuts through the middle of the state. Everything to the east of that and south of that is very flat, and it's hard to get one-dimensional analysis in a lot of those counties, especially as you start to get down close to Florida, you get over towards the coast. So 1D modeling, we continue doing 1D models where it's needed. We're using HEC-RAS 5.0. We're using regression equations. And as far as the events, we study all the events we normally do. So the theory is we'll give you all that information, but if, like I said, if we decide that we need to update your maps because the effective stuff is not nearly accurate enough, then we have all these things studied. We can go right into the mapping phase for the most part and knock those maps out a lot quicker. One more slide, please. There we go. So BLE goals. FEMA has a set of goals. They came up with the base level engineering and how it was going to impact the overall NFIP, and they came up with their goals. The first is continue building a digital inventory. Right now in Georgia and across the country, there are a lot of streams that are not model back. There isn't any engineering data to really support those floodplains. So they want to continue doing that. They want to improve the currency and the accuracy of the existing inventory using things like LiDAR and updated information. Cheaper production of flood data. Like I said, we're doing this on a HUC-8 basis. We go in and we knock it all out at once. We get a lot of efficiency by doing hydrology for an entire HUC-8 as opposed to doing it stream by stream. And then quicker delivery of data. This is BLE data, doesn't necessarily, you're not going to get a new effective map. So we get done with this information. It mostly covers Zone A areas, which is a real thorn in the side of communities, having to come up with BFEs for those Zone A areas. And because it's a Zone A area, we can hand this data to you when we're done with it. It's gone through our processes and use it as best data for all your purposes. And we'll go over those purposes later on. So what is Georgia goals? Of course, we want to support FEMA's goals. And we want to add to it to kind of make sure that we're getting the information out to you the way that, that is kind of, I wouldn't say unique to Georgia, but certainly, that you would need. The first thing is we're studying greater than 15,000 miles of previous floodplains that are based on NED topography in areas where we have LiDAR. So if you look through over there to the right, you'll see some images. The top images is what basically, if you look at the NED, there's little squares. The first thing is each square is only going to have one elevation, and they're approximately 33 feet apart. But if you look at the LiDAR, you got 1 foot spacing, and each of those have an elevation. So you get a lot more detail. So looking at the images in the middle, you start to see things like the roads. You see the building pads, actually where it's been graded and it's gone down on there, which you don't see on the NED. So if you go down to the contour images at the bottom, you can see the contours kind of show those flat areas at the pads. They show the stream in more detail. They show little ditches going in to the streams. It's just a lot more accurate, and we're able to really assess and update our models. Of course, we want to increase the community engagement, and that's part of what we're doing here today. We're going to communicate these results to you. We're going to tell you how, different ways in which you can use this data. We're starting that process today. We will continue that as we do BLE. And then here at Georgia, we want to provide tools for you to use that BLE. So we're not just going to dump a whole bunch of models on you and say, here, you got some models, you can grab some BFVs and do some planning on. We're going to set up some tools, and we'll show you some of that, that you can go and get this information. Okay, next slide. So here is what we've got. This is our 3-year plan starting in FY19. We do currently have funding for all this work. So everything you see on here is currently funded. In the map there, the dark green are areas where we've completed BLEs. The light green are areas that we've have in progress. And in fact, those are mostly complete. We have a few missing areas. LiDAR area where there's LiDAR, we don't have LiDAR, so we're kind of holding up things a little bit. And then everything else in blue is what we have planned, we have funding for. And if you kind of see there, you can see that it basically outlines the fall line I was talking about earlier. We decided to start in South Georgia because really everything above that starts to get into the Atlanta metro area. And we have a lot of good modeling that's based on LiDAR already. So we get more bang for our buck by starting in the South, kind of moving up. I think we'll probably be going into Northwest Georgia next. And you can see we've kind of already started there in North. Okay. I'm not seeing the next slide. Did I freeze or something? Somebody talk to me. There we go.
You may have. Yeah, I think the next slide is up, but you're not
okay,
seeing it.
I got it now.
Carry on. You got it.
Nope.
Okay.
I got it. I'm sorry. I was having a little problem there. So base level engineering tools, I said we want to create some tools, and we've done that. So starting in the bottom there, we've created a story map that kind of really just walks you through everything BLE related from a FEMA and Georgia standpoint. It is very useful. I would recommend going in and grabbing that. The playbook is something that we're going to be showing. Most of this presentation set up talking about things from this playbook, so we'll get into that a little bit later. And we have a BLE viewer, which is where we're going to house all the information that you can go in, just like any other map viewer, look up an address, get a BFE, that sort of thing. And this can all be found at that link there at the top, georgiadfirm.com/BLE. Shannon Brewer and I, we did a lunch and learn a month or two ago on the BLE viewer, and that link down there at the bottom, you can go see a recording of that if you missed it. I think it's a really good overview of what the BLE viewer is and what it can do for you. Okay, Jarrett. So really, let's get into, I'm going to pass it off here, but we're going to start looking through the sections of the playbook. So we've really broke this down into 3 main components there. So you not only have the BLE, but the playbook will tell you how you can use that for floodplain management, how you can use that for planning and design, how you can use that for emergency management. And Jarrett, Petia, and Megan are going to walk us through some of that here. And I think, Jarrett, I think this is where I'm going to turn it over to you, if I'm correct.
You are correct. Thank you, Joe. So we're going to start by talking about how base level engineering or BLE data can be used in support of your floodplain management activities. And there's a lot of activities that can really be supported by having this analysis in your communities, but most particularly in areas that are designated as Zone A, where maybe you don't have BFEs readily available. As well as in areas where maybe you don't have special flood hazard area identified. For some of the analysis that Joe was talking about, we are carrying it up to, looking to carry it up to a consistent distance up the watershed, or up to the 1 square mile drainage area. And so in a lot of communities, you're going to have a bit more analysis than your effective firms show, which can be helpful in showing the risk in additional areas in your communities. So one of the first ways, probably the most basic way that BLE can be used in support of your floodplain management activities is in support of essentially the minimum NFIP standards, which require you to permit all development, review all proposed development, and then ensure all new development is reasonably safe from flooding. So the BLE data can be used to inform new building construction, substantial improvements, as well as substantially damaged repairs to substantially damaged buildings. And so it can do this through the use of the estimated BFEs that are available through the BLE analysis, through Georgia's BLE website. So you can use those BFEs when you don't have BFEs readily available on your effective firms in those Zone A areas. And then you'll also be able to, as Joe mentioned, download and modify, if necessary, the BLE engineering models. So we will be making those models available on Georgia DFirm for you guys to download to maybe review existing projects or post-project conditions. And that can be handy in those Zone A areas where maybe not only are the BFEs not readily available, but also maybe the modeling is not readily available as well. Then going a few steps further, there's a number of ways where the BLE data can help inform better enforcement activities, going above and beyond those minimum NFIP requirements. It can help with informing freeboard activities. If you want to regulate to a freeboard on the BLE viewer, we will have a grid-based product to show you where the additional flows would go if you had an additional 1 foot or 2 feet or 3 feet of flooding above that that base flood elevation, the 1% analysis. It can also inform a number of planning decisions. It might spur the potential for planned unit development practices, looking to reward developers for constructing new developments that completely avoid placing parcels in the high-risk flood zone. And in contrast to that would be conventional development, which maybe doesn't necessarily discourage future buildup in those high-risk areas, which would be create obstacles and so forth in the event of a flood. BLE can also be used to inform open space preservation projects. So going back to the notation that the analysis in a lot of cases is going to go further upstream than some of your effective FEMA products Zone A analysis, you'll be able to see large areas that maybe are undeveloped that are shown to be at risk by the BLE analysis. And those might be possible sites for open space preservation projects. And it doesn't mean that you have to keep those unused. You might be able to use those for community recreation areas that are amenities for surrounding neighborhoods. And last but not least, the BLE can help inform the placement of critical facilities, whether you have critical facilities that are protected from flood risk, existing critical facilities, as well as the access to critical facilities. Seeing those high-risk flood zones from the BLE can inform any one of those aspects of critical facilities. And when you're talking about better enforcement or enhanced enforcement, it's always good to consider the community rating system. This is a program offered by the National Flood Insurance Program that looks to reward communities for going above and beyond those minimum requirements. And for that, there's a point system where you acquire points for doing more and more activities, and that translates to an insurance premium discount for your constituents. So currently in Georgia, we have around 50 communities that are participating in the CRS program. And for those 50 programs, the savings really adds up for their constituents. So annually, there's a total of over $6 million in savings on insurance premiums. That translates to roughly 80 bucks per policy. So there's a lot of savings to be gained there. And you do have to do things in the appropriate way to get credit, but the BLE being an additional flood risk data set that's not on your affected products could be a way that you could get some of those points depending on how you're using that data. So one of the ways that you could use the BLE data to inform your CRS activities is in conducting targeted outreach activities. Looking at those particular areas of your community that are at risk outside of just being in the special flood hazard area. So if you're looking to target those communities, that would be one way to get CRS credit. And going back to, I mentioned the analysis for the BLE goes beyond, in a lot of cases, the effective analysis, looking at those vulnerable populations that you have in that excess analysis area from the BLE, and looking to conduct targeted outreach activities that speak to those populations and let them know that there is a risk that just isn't shown on those effective FEMA flood insurance rate maps, and that they may want to consider to purchase flood insurance given that risk. You can also look at the 500-year analysis in the BLE. A lot of Zone A's across Georgia don't have a 500-year analysis in floodplain. The BLE will have that. So those would be populations that are outside of the SFHA, but at a moderate level of risk. So there might be a group that you would want to communicate that risk to. And then also there's folks who live downstream of high hazard dams, looking at those populations, maybe if they're outside of the SFHA, but they have an additional level of risk just being downstream of a looming dam. The BLE data can also support M.A.P amendments. It can be, you can get, if you don't have BFEs readily available in your effective Zone A areas, you can use the estimated BFE from the BLE analysis on your elevation certificates. It might require a community letter of support, supporting that BFE that's derived from another source outside of your flood insurance rate maps. We have in our Georgia BLE Playbook an example of what one of those support letters might look like. So if you're interested in using the BLE for M.A.P amendments and LOMAs, I would encourage you to check that out. Now, this isn't something new, and it's not necessarily directly tied to the BLE, but you can also use the LIDAR, all this new LIDAR that we're talking about that the BLE will be based on. You can use LIDAR to support your LOMA applications. So the BLE in those Zone A situations, the BLE can be used for the water surface elevation, giving you that estimated BFE. And then the LIDAR can be used if it's a certain quality, which most of the LIDAR currently being collected across the state of Georgia, it meets that quality requirement. You can use that LIDAR for the lag of structures. So you can kind of use two different data sets than might be traditional. There is some requirements, buffer requirements, depending on whether you're using LIDAR-derived contours or the raw point data. Where you have to add a couple of feet just out of abundance of precaution. Traditionally, for LOMA applications, we're using survey data, which is much more accurate than LIDAR, even though LIDAR is pretty accurate in itself. So there is a buffer requirement to that. So important to talk about insurance. Just very briefly, I want to start by just saying that BLE cannot influence insurance. It's not part of your effective FEMA product, so it does not influence your flood insurance rating. However, it can remove, through that LOMA, that letter of MAP amendment process, it can remove the mandatory purchase requirement for flood insurance. So that's one way that it can influence things. Now, FEMA is, and the NFIP is on the precipice of modifying their insurance rating program. That is to take effect for new policies starting in October and for renewal policies in April of next year. But they're actually changing their insurance rating so it better reflects risk, true risk, and that it won't necessarily be based on the flood insurance rate maps anymore. The mandatory purchase requirement still will be using the flood insurance rate maps, but the insurance rating itself will be using a number of different data sets. And one of the things that they intend to use, there hasn't been a lot of information released on this, is mitigation credits. They intend on giving mitigation credits in certain situations. And so I will say that that's probably something to keep an eye on as the new policy changes are rolled out. What kind of credits could be garnered, and could any of those credits be informed through the use of BLE data, such as adding freeboard, or one of the things that I think was speculated might be a potential mitigation credit is adding flood vents. So if you're using the BLE analysis to elevate a new structure, and maybe it has a crawl space, including flood vents in that structure, could potentially translate to mitigation savings. But so BLE doesn't directly influence your insurance premiums, but it can influence that mandatory purchase requirement. And last, I just want to point that many of your ordinances already have language. If they're following the latest Georgia model ordinance, your ordinances may already have the language necessary to use the BLE data as best available information in those Zone A areas where you don't have BFEs readily available. If you're unsure, if maybe it's been a while since you've updated your model ordinance, your floodplain management ordinance, you can pull the model ordinance for Georgia from georgiadfirm.com, and you can compare and contrast to make sure that you have the appropriate language in your ordinances that you can take advantage of using this BLE analysis. And if you're unsure, if you're still unsure after pulling that, and you have questions about how you can use the BLE analysis in support of your day-to-day floodplain management activities, I would encourage you to pull the BLE Playbook, as well as reach out to the Georgia DNR floodplain management staff. They review ordinances pretty frequently for communities across the state and are very knowledgeable and will likely be able to help you. So this brings us to our first poll question. I want to remind you, as Emily said, that if you want to get continuing education credits, you're a CFM and want to get continuing education credits, you have to respond to this. Doesn't necessarily mean that you have to have it right. You just have to respond so that they know you're here. So I'm going to pull that up, and it'll give a timer, but we're just going to give it probably less than a minute for y'all to go ahead and respond. You should be seeing the prompt for that polling question now. See a number of you have not started, and I'm getting a bunch that are in progress. Hopefully you are all seeing that. And give it a short amount longer, and then I'll close the poll and we'll be able to keep trucking. You do need to answer this if you want continuing education credits. And this is one of two poll questions. Okay, just a couple more seconds. All right, we're going to go ahead and close the poll. Looks like it's giving 15 more seconds. And where the poll is completely closed. I think there were a couple people maybe were still in the process of answering. All right, so that poll is closed, and we will carry on with the presentation, but I will be passing the torch to Petia, Doubrovska, Elivia to carry on through part 2.
Thanks, Jarrett. Next slide, please. Okay, the base level engineering playbook and the supporting engineering data can be used by various departments within a community, as well as engineers and developers to support their effort to minimize the flood hazard risk and to increase the community resilience to disasters. In the next couple of slides, I'm going to cover some application of the base level engineering data for planning, design, and other applications. Next slide. So base level engineering data can be used for zoning planning. As Joe mentioned earlier, the base level engineering analysis are watershed-wide analysis, and they provide spatial and visual representations of the existing flooding risk, even in areas that were previously not identified as a special flood hazard area. The community official may utilize this special information and overlay their current existing zoning maps to identify any areas that needs to be updated. So basically they can strategically plan to avoid any areas which are flood prone in effort to minimize the losses and damages to properties or infrastructure. Next slide. The base level engineering datasets can also be used for better future development planning, aiming to reduce or eliminate the economic losses due to flooding. While the standard DFARM maps and information are providing information about the extent of the floodplain, let's say the 1% or the 0.2% floodplain extent, they do not provide information about what the depth is going to be in a particular location. Or if you look at the maps, you cannot identify what the water surface elevation is going to be again at a particular property. For comparison, the base level engineering data and the supporting data sets can provide this additional information, and that can actually help engineers and developers be actually better prepared and informed about the existing flooding risk and plan accordingly to avoid any potential losses. Community officials and engineers can actually review the available data sets and place new buildings or critical facilities in areas which are not flood prone. They will avoid future losses and also can potentially reduce the insurance purchase requirements. In the example here at the bottom, the two pictures, the left and the right, are showing the implementation of the depth data set, which is one of the BLE products, to better place the proposed building, which is included in the 1% base level engineering floodplain outlines. As you can see, the image on the left is showing that the original location of the building was selected to be in the deepest portion of the floodplain. Thus, there will be a high chance of having flood damages in the future. With the overlaying of the depth grids with the plan development, community officials or engineers and developers can smartly select and better select the location of the proposed building. They can opt to shift the location of the building toward the fringe of the floodplain, where the flood depths are going to be significantly lower. And additionally to that, the developers may decide to elevate the building to keep it above the base flood elevation, to minimize any future losses, and also to prevent increasing the flooding risk in the areas surrounding this development. Next slide. Base level engineering can also be used to inform public works projects by identifying and targeting capital improvement projects and infrastructures based on the existing flooding risk and their location. So, for example, the image on the left, you can see infrastructure, undersized infrastructure that is located in the 1% base level engineering floodplain. And then you can see another infrastructure which is outside of the base level engineering 1% floodplain. The community officials can budget and allocate funds to basically work on capital improvement projects that are more critical, and they can prioritize those to make sure that the public safety will be prioritized first. Next slide. Capital improvement projects can also be ranked not just by location of the infrastructure, but also based on the existing risk. So if you have a structure which is frequently flooded with several feet of overtopping, the risk of failure will increase over time. But if you have another structure which is very rarely flooded with just a couple of inches of water, obviously more priority can be put on the structure that has a higher likelihood of failure. Another way to prioritize the capital improvement projects will be depending on the consequences of failure. So the images on the right are showing two examples. So if there are some critical infrastructure or some kind of a critical development like school or hospitals located downstream of an infrastructure, in case that this structure fails, obviously the impact of the failure will be having significant consequences. If the structure is located just upstream of undeveloped and rural area, even if this structure fails, the consequences are not going to be that significant. So again, community officials may prioritize their investments and allocate their budget accordingly to work on more critical capital improvement projects. Next slide. Base level engineering data can also be used to support planning vertical alignment of proposed roads or road improvement to make sure that they are properly elevated. A community official may overlay the base level engineering floodplain with their aerial imagery or maps to identify any roads which are flooded and are providing only access to a development. On this image to the right, you can see a road that will be frequently overtopped and is currently providing the only access to a residential subdivision. This information actually can help community developments to plan bridge upgrades to make sure that access will be provided to the subdivision, or plan alternative routes that can be used in case of evacuation planning and in case of emergency. The local government can also utilize the base level engineering data sets to identify flooded access routes to critical infrastructure, like this image on the left, where we have pump station. The access road to the pump station is going to be flooded. So that information can inform community officials to better planning in case of emergency. Next slide. Base level engineering flood hazard data sets and the supporting H&H modeling data can be used to inform floodplain management efforts for various engineering and design projects. And here we have listed several examples of when the base level engineering analysis and results can be utilized and support design projects. So the first example is when we have a proposed development adjacent to effective special flood hazard area zone AE, but not encroaching on it or not encroaching on the 1% base level engineering floodplain. In this particular case, for your development, you have to utilize the effective base flood elevations, as you know, they will be based on more detailed studies developed for the zone A areas. So if you have to plan a building, make sure that this building is properly elevated, you have to use the base flood elevation based on the effective maps. The second example is if you have a development project adjacent to an effective special flood hazard area zone A, but not encroaching on it, and also not encroaching on the BLE 1% floodplain. In these particular cases, if no base flood elevation is available for this zone A area, you can utilize the estimated BFE determined by the base level analysis to and utilize that for your regulation purposes. The third example is if you have a land development project that is outside of the effective special flood hazard area, but is proposing encroachment on the 1% floodplain based on the BLE analysis. In this particular case, it is recommended to evaluate the impact of the proposed development over the flooding risk near the property, utilizing the base level engineering modeling, the H&H modeling. Next slide. And the last two examples are, the first example is if you have a development which is proposing an encroaching on the effective zone A area and or the 1% base level engineering floodplain, and the BLE analysis is the only available modeling data. In this particular case, we recommend utilizing the base level engineering modeling, scaling it down to just your project area, and also developing corrected effective model. Utilizing the base level engineering, you can incorporate additional data. If survey data was collected prior to the development, you can decide to modify the topographic data. If you want to add more details, again, like you can incorporate break lines to capture some topographic features. You can also decide to modify the Manning values if you want to add additional details to the base level engineering model to have a better corrected effective model. And also you can, using this model, you can develop a proposed modeling which incorporates the proposed development and the proposed grading on the site. And you can compare the two modeling data to determine if the no-rise conditions are met before issuing a permit. And the last examples is when the proposed development is encroaching on the effective zone AE special flood hazard area. In this particular case, it is recommended to utilize the FEMA effective H&H modeling for the flooding source, and still the base level engineering data can be utilized for validation of the effective modeling data. As Joe mentioned, the BLE modeling is based on LiDAR data, so you can utilize the topographic data in the BLE modeling to check the cross sections in the effective model if they really reflect the current topographic conditions, or if you have to develop a corrected effective model. And also, depending on the type of the effective hydrologic modeling, you may utilize the BLE modeling to validate the flows in the effective hydraulic model, and also determine if some needs of updates of the effective hydraulic model are needed. And next slide. Base level engineering analysis can also be used to support other applications. As Jarrett mentioned previously, in a zone A areas, you can utilize the base level engineering analysis to submit for LOMA, CLOMA, or LOMA-F applications. You can also utilize it to again, for zone A areas where base flood elevation is not available, to provide information for the BFE and elevation certificates. Also, if you're preparing floodproofing certificate for non-residential building, you can utilize, for zone A areas, you can utilize the BOE results. And lastly, for homeowners or developers, they can utilize the estimated BFE to make sure that their utilities like HVACs or electrical system are properly elevated to be safe from flooding. And next slide. And as John mentioned, the engineering analysis supporting the base level engineering studies can be two types, 1D and 2D type analysis. If the analysis for the analysis which are based on 2D methodology, you can utilize the hydraulic analysis to develop dam break modeling. Utilizing the sunny day dam bridge approach, which is the standard bridge modeling for Georgia. With this type of modeling, no hydrologic input is required, so you have to make sure that once you receive a copy of the hydraulic modeling, you have to remove any hydrologic inputs, so precipitation or inflow hydrographs, they have to be removed from the model in order to properly model the sunny day dam bridge. After you complete this modeling, you can utilize the inundation area mapping downstream of the dam to support any EAP maps preparation for the dam. And the last thing that I wanted to mention is that the base level engineering can also be used to support sanitary sewer system rehabilitation projects in areas where infiltration and inflow from of stormwater into the system is of concern, as you know, this can cause overflow and also can increase the burden to treatment plants downstream. So using the depth grids and the floodplain mapping data sets from the BOE deliverables, you can identify any flooded manholes, sanitary sewer manholes, and continue to plan improvements and further investigate areas where you need to make upgrades to minimize the infiltration into the sanitary sewer system. And that's all I had. And with that, I'll pass it to Megan.
Awesome. Thank you, Petia. So the last section of our BLE playbook focuses on emergency management. And this section was developed in collaboration with GEMA, the Georgia Emergency Management Agency. So thank you to our friends at GEMA for all your input and feedback when developing this section of the playbook. Next slide. So can BLE data be used to support emergency management activities? The answer is yes, absolutely. BLE can be used before, during, and after an emergency event. And so we'll talk about some more details about that. Next slide. Next. So we'll start with talking about mitigation planning. And within the plan update or development process, there are a number of steps where BLE data can be used, including reviewing community capabilities, conducting a risk assessment, developing mitigation strategies, and creating safe and resilient communities. Next slide. So early on in the mitigation planning process, an important step is to review community capabilities to understand what resources you have and what tools are available. And so now this BLE data is a new tool at your disposal when you're developing your mitigation plans. And we mentioned earlier, it can be used as best available data and often extends higher in the watershed where mapped special flood hazard area might not exist. Emergency managers also have the flexibility to choose which products you want to use, whether it be the effective SFHA, local community products, or the BLE data. And for communities and emergency managers that don't have access to GIS, BLE data is also available through the Georgia DNR BLE web viewer. Next slide. Another important step in mitigation planning is conducting a risk assessment to understand where your risks are and where your community is vulnerable. So for example, BLE depth grids can be used to show flooding and vulnerability of critical facilities. They can be used for evacuation route planning to identify roads that are not safe for travel. BLE depth grids and building information can be used with FEMA depth damage functions to identify areas of significant monetary damage. And lastly, BLE probability grids can be used to identify areas that have a higher chance of flooding more frequently. So these are all examples of identifying where the greatest risks are within your community. Next slide. And then once we've identified the areas of vulnerability and high risk, we can then develop strategies to mitigate that risk, as well as rank and prioritize the mitigation actions. So some examples include using BLE floodplains to inform more resilient development decisions, using BLE floodplains to identify areas for structure removal or relocation, and then using the BLE depth grids to inform elevation of structures and utilities. Next slide. And one of the final stages in mitigation planning is creating a safe and resilient community through implementation of your mitigation strategies. Oftentimes, communities will have a long list of mitigation actions, but often will need funding to help implement them. And there are a number of opportunities through FEMA for this, including HMGP, BRIC, and FMA, but these all require a community to demonstrate cost effectiveness. And so the BLE data can be used to support the development of benefit cost ratios. For example, homes within the 1% BLE floodplain can use pre-calculated benefits rather than FEMA's BCA toolkit, which is great for areas that don't have mapped special flood hazard area. BLE depth grids can be used to determine depth of flooding above the lowest adjacent grade of structures. And they can also be input into FEMA's HAZA software or the Corps HEC FIA to calculate the monetary losses and estimate the damages without project implementation. Next slide. BLE data can also be used to support education and outreach efforts to make communities more resilient, both through educating the public on the flood risks and hazards, as well as advising community officials in support of capital improvement planning projects. Next slide. So moving on to disaster response, BLE data can be used to help emergency managers make decisions during an emergency event, and they can be used to simulate real-time storm events. We do recommend that if you're using any of these BLE models for real-time simulation, that you utilize experts who are familiar with the modeling processes and interpreting the results. But BLE depth grids and floodplains can help emergency managers screen for areas that are flooded and might need assistance. And they can also be used to help prioritize staging of flood defense resources like equipment, sandbags, detours, roadblocks, things like that. Next. So then moving on to disaster recovery. BLE products can help communities recover more quickly and resiliently after an emergency event. In the short term, BLE data can be used with property data to get targeted information for programs such as FEMA's individual assistance and public assistance out to homeowners and communities to kickstart recovery efforts. It can also be used to identify areas that might need damage assessments, debris removal, and high watermark collection. Next slide. And then lastly, looking at recovery in terms of long-term resilience. BLE data can be used to show if any proposed rebuilding efforts are located in high-risk areas. And they can also establish estimated BFEs to assist with the permitting of any rebuilding of substantially damaged buildings. So just to very briefly sum it up, there are a lot of ways that communities can use BLE data. And I would really encourage everyone to check out the BLE Playbook, which goes into a lot more detail on all of these things, which was included earlier in this presentation. And with that, I'll hand it back to Jarrett.
Thank you, Megan. And apologize for the jolting slides. My mouse wheel got carried away. But we've got our second polling question. Again, to receive continuing education credit, you'll need to answer this. So I'm going to go ahead and open up this poll. And somebody I saw noted that in the chat that to be able to respond to the poll, you have to have the chat box up, it sounds like. So that is open, and we're going to give it just a minute to get your responses and then we'll wrap things up. Give it just a minute longer or a few seconds longer. I think everybody who was answering has put in their responses, so I'll go ahead and close the poll. Save this real quick. Sure we don't lose that. And we'll go ahead and wrap it up. We have a slide for resources as well as contact information for the presenters in case you have additional questions down the road. Hopefully a number of these resources will come in handy to you. We also had one of the intro slides, a link to Georgia's BLE landing page, as well as the last BLE presentation that we gave a few months ago. And with that, we'll open it up to for Q&A. If anybody has any questions, please use the chat or the Q&A box for that. Also, for continuing education credits, we do need folks to add their name.
Not yet. Not yet.
Oh, not yet.
Not yet.
Emily,
Let's give us a sec. Give everybody a second to put any questions you've got in the chat, or
Okay.
excuse me, not chat, the Q&A. Currently, we don't have any, so if you do have one, now's a great time to throw it in there real quick. Yes, this PowerPoint will actually be emailed out to all attendees rather than be on a download. If you did not receive it within a few weeks, please let me know. Just shoot me an email at emily.wingo@dnr.ga.gov, and we'll be sure to get that to you. Also, if you have been to the Georgia DFirm website and you were looking for those, if you can't remember, what was that link that Jarrett put up, be sure to put it or look for that YouTube link that's on the page, and it'll take you right to it. Let's see, we do have another question. In the beginning, you showed a map where the BLE is available, and it appears not to run in the Jackson, Barrow, Hall, and Gwinnett area. Is this right? And if so, will it be available? And Joe or Jarrett, y'all want to take that one?
Yeah, I can take that one. I'm trying to turn my video on. Jackson, Barrow, Hall, and I can't see the chat. What was the other one?
Gwinnett.
Gwinnett. Yeah, we are currently in the middle of two different projects. So the first one covers the ones that were mentioned except for Jackson, and we're getting ready to start Jackson. So we're not doing BLE there in the sense that we're just doing the engineering. We are doing full-blown mapping projects. And of course, you can find information about that on georgiadfirm.com. Or if you have specific questions, just give me a call, and I'm happy to walk you through the scope of those. But we currently have prelim maps out for the three, and we're starting on Jackson and Greene County. That's all in the Upper Oconee watershed, and we have maps underway, do engineering analysis. So there was no reason to do BLE there, if that answers your question.
Great. Okay, with that, we don't have any other questions, but if you do think of something, please feel free to reach out to us. Thank you again to Joe, Jarrett, Petia, and Megan for that very informative webinar. I hope everybody now has a better understanding of BLE and the Georgia DNR's BLE Playbook. We're offering one continuing education credit for today's session, available only to certified floodplain managers that completed the polling questions and provide us their name and email address in the chat now. So please be sure to open that chat box up and put in your name and email address. Again, we will be distributing the slide deck and a survey that we'd greatly appreciate you completing. If you're requesting continuing education credits, those certificates will be emailed separately. Finally, mark November 3rd from 12 to 1 on your calendar for the next Lunch and Learn webinar. So be on the lookout for that invitation and make sure to sign up. With that, thank you again for attending today's session. For any of you who don't have any more questions, this is the end of our Lunch and Learn. Have a great day, everyone.